Find in ascending power of x the first three terms in the expansion. 1 plus 2x raised to power 7. It's 1 plus 7c1 b1 plus 7c2 b2. These are the first three terms. Seven C1 is 7 times 2x plus 7C2 is 21 times 4x square. 24x square. So these are the first three terms. Then it says, hence find the coefficient of x square in the expansion of this. B part is 1 plus 2x raised to power 7 and 1 minus 3x plus 5x square. 1 plus 2x is already 1 plus 14x plus 84x square times 1 minus 3x plus 5x square. And we're looking for coefficient of x square.
So that's the second term.
Yeah, that would depend if it is second term or third term, depending on the power. See, in this case, then this is the third term, x square. So when I'm looking at this one, I'm ignoring the first one, 1 into 1, 1 into minus 3, because I'm not getting x square. Multiplying this with the last one, so we get 5x square. And then when we look at 14x, I ignore the first one, multiplied with the second one. 14 into 3 is minus 42x square. And then 84 into 1 is 84x square. Other than that, we don't get x squares. So 5 minus 42 plus 84. So coefficient of x square in the expansion is 47.
So we basically just multiplied like into both of the equations to see how we would get x squared.
Yes.
Okay.
We can multiply complete terms, but we just needed x square. Question number 847. Yeah. Okay. Question number 9. This is a different type. Try this.
A part, I'm getting the same answers.
Yeah. Now see the B part, that's a little different. How will you do this? It is related to A part.
Do we factor the inside?
That's already factorized.
Then we would continue solving it like A part, like with the.
Yeah, but these are three terms. The difference is these are three terms. So what are we going to do is if you consider this part as x, this is 1 plus x in the first part. So we can replace everything rooted in x with this y minus y square. So see closely, this is 1 plus 7 into y minus y square. I'm copying this plus 21 into y minus y square squared plus 35 into y minus y squared cube. That's how we'll get the coefficient of y cube.
So y cubed is the third term, so it's the 35y minus 35.
Third term,
No, I
y.
mean fourth term.
Yeah, that too would depend where we're expanding it. We can't actually number the term. It may be different in all the series. 1 plus 7y minus 7y square, 21. Now we open the square, that's a square minus 2ab plus b square plus 35. I'm opening this at the side. Y minus y square whole cube is actually y minus y square into y minus y square squared. So y minus y square into a square minus 2ab plus b square. Y in all of these is y cube minus 2y4 plus y5. Then y square in all of these is minus y4 plus 2y5 and minus y6. Once done, if you can see, the only term in y cube is this. All the other terms are more than y cube. I don't need those, so y cube, ignoring the rest. And what was the requirement? Find the coefficient of y cube in the expansion. So 1, 7y, 7 square could be left out, 21 into y square could be left out. 21 into 2 is minus 42 y cube, y4 is left out, 35 y cube. So 35 and 42, the difference is 7. Minus 7. This was 9b. 9b minus 7. Clear?
Yes.
Okay. One more and then we'll go on to the next topic. 11. Find the term independent of x.
Are we gonna do the challenge?
Sorry?
Are we gonna do the challenge?
Try 11. I'll read that question.
Okay.
We can do that.
But when it says independent of x, like what does it mean by that?
Constant term. Power of x will be 0.
But even like the first term is x to the power of 9.
Yeah, you don't have to do that directly. That thing. Try that thing. NCR A n minus R B R, and then expand and separate x and separate the numbers and equate power of x with 0 because we need independent.
So n minus r has to equal to 0.
R could be anything, but x raised to power would be 0.
But 1 equal to 0 be 1?
Like, have you expanded it or you're making a guess?
No, because it would be power to 0, right? So wouldn't that be 1?
Let me try. Power 9. So this is 9CR A 9 minus R B R. Now I'm separating the numbers and x. 9CR multiplied with x raised to power 9 minus R multiplied 2 raised to power minus R multiplied with x raised to power minus 2R. Numbers on one side is 9CR dot 2 raised to power minus R, and writing x at one side is x raised to power 9 minus 3R. Now we need this part as x raised to power 0 because we need term independent of x. Therefore, we can write x raised to power 9 minus 3R is equals to x raised to power 0. So 9 minus 3R equals 0. 9 is equals to 3R. So R is 3 at that time. There will be no x with the term when R is 3. So the coefficient is 9C3 into 2 raised to power minus 3.
So how did we expand it from the first part to the second part though? So it's 9CR times x 9 minus r and then times 2 negative r times x negative 2r.
See, this is the generic term. This is 21 by 2. Let me just confirm and I'll explain. Yeah, 10.5. See, when we expand this, the formula was supposed to be 1 plus nc1 an minus 1 b1 nc2 an minus 2 b2 and so on. So it keeps moving a n c r a n minus r b r and keeps moving, and the last one becomes b raised to power n. So it could be anything. We can't make those guesses right here that when power is 1, what will be the power when power is when r is 2, when r is 3, when r is 4, and so on. So we needed to figure out. So I directly wrote this term where I was unaware that what r would be. So once simplified, once we separate the constants, this is a constant, then 2 would come out to become a constant. So NCR is constant, 2 raised by minus r is constant. Other than that, we have variable x and x. Once separated, we needed to know the constant term. In the constant term, power of x will be 0. So we equated that with 0 and got r as 3. If they would have said that find the coefficient of, let's say, x cube, so we would have equated 9x r is equals to 3. So in that case, r would be 2. So coefficient of x cube, to find the coefficient of x cube, I'll use r as 2.
I'm still kind of confused from how we got from the first part to the second part.
First part in green.
Yeah, no. First part in red and the second part in yellow and blue.
Okay. You got the concept why we are using 9CR.
Yeah,
Now,
I know the reason for that.
in this, I'll write it again.
I know why we use 9CR.
Okay. 9CR x 9 minus r and 1 over 2 x square raised to the power r. And you need to know how we are getting this, right? So the first one is already clearly 9CR. It is multiplied with x raised to power 9 minus r. Now we need to split this number and variable. May I write it like 1 over 2 power r into 1 over x square power r?
Okay.
So 9CR into x raised to power 9 minus r. This becomes 2 raised to power r in the denominator. When you bring it in the numerator, power turns to minus r.
Yeah.
1 over 2r, 2 raised to power r could be written as 2 raised to power minus r. Same case with 2. This is 1 over x 2r in denominator. When you bring that in numerator, it becomes x minus 2r indices. Now we write the constants with each other and variables with each other. So 9CR into 2 raised to power minus r into x raised to power 9 minus r into x raised to power minus 2r. So 9CR into 2 raised to power minus r into basis same powers add 9 minus 3r.
Wait, how did we get 3R? Oh, because we added the 2Rs. Okay.
9 minus r plus minus 2r. Okay. Now there's a formula how we can write C. If we like how the how calculator is handling this part is NCR, the expansion is n factorial divided by r factorial into n minus r factorial. So basically, if someone would say 10C4, we'll write 10 factorial over 4 factorial into 10 minus 4 factorial. So 10 factorial or 4 factorial into 10 minus 4 is 6. 10, 9, 8, 7, 6 factorial over 4 factorial into 6 factorial. This could be cancelled out. And that's 10, 9, 8, 7. Although we have calculators, 4, 3, 2, 1. So 4, 1 times, 4, 2 times, 2 with 2, 3, 1 times, 3, 3 times. So 3, 7 times is 21, 21 into 10 is 210. So 10 C4 is 210. 10 C4 is 210. So this challenge part, it says that when a plus ax raised to power n is expanded, the coefficient of x square and x cube are equal. One plus ax raised to power n. When we expand this, we get 1 plus n c1 b1 plus n c2 b2. Simplifying nc1 ax, nc2 a square x square, and one more term, nc3 ax cube is nc3 a cube x cube. Now the question says coefficient of x square and x cube are equal. So coefficient of x square is this, nc2 a square is equal to coefficient of x cube, which is this, nc3 a cube. So we can solve this. If I divide them, nc2 divided by nc3, that will be equal to a cube over a square. The right hand side is simple a and left hand side I'm expanding that. So this is n factorial over 2 factorial into n minus 2 factorial over n factorial over 3 factorial into n minus 3 factorial. We are solving for a. N over 2 factorial into n minus 2 factorial into 3 factorial into n minus 3 factorial over n factorial. So we get rid of this first. And now if you look at this, may I just expand this n factorial n minus 3, or I'm writing it as it is, and that's 2 factorial into n minus 2, and the next number is 1 less than that, so n minus 3 factorial.
What do you mean by the next number?
Next number, like 5 factorial is 5 into 4 into 3 into 2 into 1. So we can write 5 factorial as 5 into 4 factorial, or we can write 5 into 4 into 3 factorial, or 5, 4, 3, 2 factorial, or 5, 4, 3, 2, 1
Oh, okay.
means this. So I was looking at this n minus 3. So and the denominator is n minus 2. So next number 1 less than that actually makes these both equal.
So 3 factorial divided by 2 factorial, same thing.
So 3 into 2 into 1, 3 factorial is 6. 2 factorial is 2. And minus 2 is equals to a.
Wait, how did we get that?
3 factorial. 3 into 2 into 1. 6.
Oh, okay.
Okay. Find a in terms of n. So a in terms of n. This is 2 1 times, 3 over n minus 2. Three over n minus 2. Next subtopic is a little different from this, keeping in mind that we also have to cover it up for and make time for past paper practice. So in your free time, do come back to this exercise. This would need a little more practice.
Okay.
Okay. Next in series is arithmetic progression.